Hello, everybody. My name is Matthew Zamora. I'm the president, I'm the co-organizer of MoCo Makers. We are a community, and we meet out of this space in Rockville every Friday. So what we do in our community is support each other, knowledge share resources. We fundamentally have varying topics. So we've covered in the past machine learning, introduction to electronics, what's the difference between motors and servos, how to build a multitasking Arduino, just kind of a hodgepodge really. And we go with the flow. I mean, I'm a firm believer that right now we live in an empowered age, an age where technology is cheap, knowledge is available, and we just have to apply ourselves, and we can do some pretty cool things. So part of that is self-development, and part of that is emboldening yourself by leveraging the community, the resources available to you. So I'm not here to present something that I work on. I'm not here to present something that I am the expert at. I'm here to present something that I have solved in the way that any of our DIY community members would have solved it, which is just tenacity. Maybe it's not elegant, it certainly differs in a lot of ways from the Department of Energy cluster that we have downstairs. But it's a solution, and it works, and let me dive into it. So we are talking today about a cluster of Raspberry Pis. You get asked a lot, why would you build a cluster of Raspberry Pis? And the answer is A, because it's cool. B, it is cheaper than a lot of other solutions. And it just gives you some hands-on exposure with the big data world, the cluster computing world. So it's also I think a little bit related to the fact that Raspberry Pis are a good introductory investment. So if some of you are new to electronics or just becoming more familiar with it, you get one of these, you get two of these, and they will serve you for robotics projects, they'll serve you for file servers, and they'll serve you for clusters. So again, I'm Matthew Zamora. You can reach me at matt@mocomakers.com. Feel free to ask me for any help, or if you have any event suggestions. We're always looking for guest topics, and if we don't know it, we can certainly learn it and have a topic on it. All right, so fundamentally, you have to choose a technology stack to do your cluster computing. Now, cluster computing is a broad term, just like big data is a broad term. But what you are looking for in this kind of software is something that makes your life easier. So that's where some of these larger, well-established, industry-tested solutions are really of aid to you. So Apache Spark, of other note, and I'll get into this soon, is Apache Hadoop. Both of those are pretty much synonymous with what people actually mean by big data. So when you hear big data, they're probably talking about cluster computing. I mean, it's the only way to deal with computations on the order of petabytes. So let me dive into the differences of Spark and Hadoop. All right, so first of all, what is Spark and what is Hadoop? So Spark is a API for executing parallelizable commands across an arbitrarily large cluster. So what that means is you have literally a set of CPUs on multiple machines, and what you're trying to do is to break a big problem into lots of small little problems that can be operated on at the same exact time. The reason, of course, would be efficiency. There are types of problems where that's useful, a large amount, and problems where that's not useful. So a fundamental example for big data would be large text file manipulation or aggregating statistics from large files. So if you have, for example, the census data of the United States, you have that. Many gigabytes, I'm not exactly sure how much, I imagine it's quite large. And you're looking to do some rather complex demographic analysis. The first question you have, of course, is, well, give me a count of everybody with Latino origin heritage, okay? Now, a traditional way to do that is you load it up on one computer and you execute a program that will sequentially go from start to end through your data set. That is a bottleneck. You know, you have to execute that on one computer on one core. What you could just as equally and should do in large data cases is segment that data. So that's where, well, I can break this apart by state. I can break it apart by every 10,000 people, have one machine look at just that statistics, give me the high-level overview of that, and then I can quickly aggregate that data in the next round. So Spark plays a role in in designing computer programs that can be executed in multiple nodes, and it takes care of all of the behind the scenes for you. So what's behind the scenes is networking protocols. You need to have data availability, and not just available, but the right part of that data available. You could never load the entire database of the census onto a Raspberry Pi, but you can send the part of it that this Pi is looking at when it needs it on demand. And you don't have to control that it's getting that subset of that data. That is a function that Spark will do for you. And another concept is Hadoop. So Hadoop takes that data distribution to another level. It is a distributed file system that has all of your data readily available, again, stored on a cluster. So they're both open source by the Apache project, and they work together very well. So there are actually, in the wild, 3 variations of Spark working with Hadoop. When you see HDFS, that's Hadoop file system. So Hadoop file system means that say your data is 10 petabytes. I mean petabytes. Again, you cannot load 10 petabytes on this Pi. However, this Pi has access to every single 1 and 0 in that data. That's what Hadoop specializes in. It is making data available. Obviously, there's some back-end, on-demand network calls, queries, moving data around, but that's opaque to you, and you want it to be opaque to you. What you generally get is a marriage between Hadoop and Spark, where Hadoop is taking care of moving data around your network, and Spark is taking care of doing intelligent things with it, the processing, the parallel processing. That said, Spark is, in some instances, a subunit of Hadoop. It came out of Hadoop. Now, there's a lot of talk that says Spark is probably going to replace Hadoop. So, you know, there's a lot of things that Hadoop does that Spark can do. For instance, Spark standalone can do some data migrations for you, but Hadoop does it better right now. So here are the 3 versions of Spark setups that you can get. Standalone. Standalone means it's installed as its own daemon or however you say that. It's its own service, and it's just running on its own without any necessity. It can call Hadoop, and the way it calls Hadoop is network address calls, just like typing in HTTP : you would type in HDFS : and that is a network file that is always available wherever. Then you have a version that involves Yarn. I won't touch on that much, that's kind of going away, but suffice it to say that Yarn is a glue between Hadoop and Spark that it's just a command line glue. Then you have Spark operating as a module of Hadoop. Now, the reason I bring this up is that if you're getting started in creating your own Spark cluster, you can be a little bit confused because you have different instruction sets depending on which version you want to make. I'm going to be emphasizing the Spark standalone version. I'm not even going to be installing the Hadoop, although that's, you know, you could do that. Again, it's optional because there is, Spark does do a lot of things that Hadoop does, including network stuff. It's just that Hadoop would do it better, and it would do it in a more conscientious way. So when you're looking for guides, look for the standalone one would be my advice. In terms of just a little bit more on the differences between Spark and Hadoop. There are speed differences between the way that they do their processing. So fundamentally, Hadoop emphasizes disk-managed data. That means things get written to the disk. Apache, the reason it's so fast and speed is the selling point of Apache Spark, is that it stores everything in the memory, in RAM, you know. So, but everything said and done, it does seem like the world's leaning towards making Spark the new Hadoop. So when we're talking about the way that Spark parallelizes your data, there are a set of functions that you'll see over and over and over and over again, and they have to relate to breaking things into chunks. So in a traditional program, a C++, Python, whatever, you were reading that text file, you would have probably a while loop or a for loop iterating through the entire file line by line, doing your statistics count or your word count. That's a loop. It's kind of a conceptual shift to get away from loops to move towards iterables and maps. So an iterable is something that you iterate through. It's something that has a sequence, and generally the intention is that you will count through that sequence. The other thing that that is important here is what is called in programming a map function. So a map function takes an iterable sequence and applies one block of code to each element in that function. A map can be done on a single core processor, it can be done on one system, but the way it would do it is it'd queue everything up, and it would do one at a time. So what we're looking to do is break that out so that when you're calling your map function, rather than having it queue it, it is dispersing those chunks to your cluster. So again, not a fit for every type of processing, but anything where you can potentially segregate or isolate your frame of reference, narrow down on chunks rather than doing something whole sequentially, it would be to your advantage. I'll just breeze through this. There are paradigms, if you really want to get into the theory of it, for what they're calling map reduce. Map reduce is a way of, again, using the map function, sending out instruction sets to each node saying, hey, get ready because I'm going to have you process 10 lines of code, of text file. And then reduce is that okay, now I'm sending you the data, go ahead and give me your result. So it's a paradigm that you can explore, but it is the foundation of Hadoop in particular. So build guides, how do we actually build the thing? There are two references that were just really valuable to me. It's these two here. I'll show you them. Let's see. Okay, I won't show you, but they're here. However, I've done you guys a great favor in consolidating it on a guide I put up on the MoCo Makers blog. So here's where the official instruction set is, mocomakers.com/blog. We only have one entry right now, so it's this topic. What's important is that there are essentially no perfect guides, and the reason is because either they assume prior knowledge, which is a stupid thing to assume, or they are just literally for outdated versions. Unfortunately, these are fast evolving projects and they're releasing things that are not reverse compatible. So you'll find serious issues with, for example, dependencies, and I'll get into that. All right, so let me dig into. I'll breeze through this part because it's, again, you want to refer to the guide when you're doing the thing. But let me go ahead and just kind of give you the blow by blow. First of all, you need to set up a physical network. What I have here is I have a router. You can use a home router. If you have a switch, which is technically different than a router, that's even better. But you know, for the rest of us who have these old things lying around, that can be your starter hub for connecting everything. What you want is ideally to have everything on a local network, and you want to have local IPs statically assigned to your PIs. You might have seen 192.168.1. Something, 210, whatever. Each of those small numeral thingies relates to your assigned device ID. So, it's part of your local IP number. Those local IP numbers are how they talk. Fundamentally, this is an Ethernet communication protocol at the lower level. So, in setting it up, there's some tricks that would be useful. I came to find out that there is actually, all Raspberry Pis share a specific part of their MAC address, so you can actually query all locally connected devices and find the one with the relevant part of the MAC address to find all IP addresses that are Raspberry Pis. This is really useful. The first thing you do fundamentally is establish what are the IP addresses of everything on my system. So you are setting up a master-slave system where you can have as many slaves as you want, but you only have one master. Generally, a rule of thumb, if there was a difference, you want your master to be a powerful computer, but you know, it's not really a deal breaker either way. You want to enable SSH. If you haven't done this yet, take a moment to enable SSH on all your devices. On the back end, when Spark is running, it will be not only using the Ethernet, but it will be using SSH to run specific calls. All right, so you're going to be working with a hosts file. What a hosts file is on any operating system, Linux or Windows, you are going to correlate IP addresses to like domain names or just names. So what we're doing here is we're setting up a file where your local IP addresses relate to names. So if you were to type in master in your setup, it would translate it to your IP address. So this is something that you want to declare, which is, at this point you're declaring the master, and you're declaring your slave, and then 01, 02, 03, 04, etc. Now let's talk a little bit about dependencies, because this is a major trip me up. Like I said, Spark is evolving very quickly. The latest version of Spark 2.2 uses Java 8 as a dependency. If you go back to 2.0, and I think even 2.1, it used Java 7. You'll just get a terrible unexplained error if you try to run Spark with 7 installed. So if you are using the latest version, time-stamped as of this presentation, the 15th of July 2017, you'll want to use Java 8. That was a gotcha. You can just go ahead and download Apache Spark from the Spark website. It's basically a tarball, which just means, like, for those of you from the window world, it's like a zip folder. You do a little bit of configuration on it. I have the configuration parameters here, the location of your Java install, the location that Spark is installed from, and then you add some stuff to your path. Everything is relative to the Spark home folder. So even when you're configuring Spark, there's a config folder in your Spark folder. When you have temporary variables that are stored, they're stored relative to your Spark folder. Some other variables that will come up. For the Raspberry Pi, you're going to want 2 cores. Worker memory, there's some flexibility. I've seen 400 up to 720. Fundamentally, you have 1 gigabyte of RAM on that, but you're going to want to leave some for the operating system. So here's where you would set up SSH. So it's a little bit of, it might be new for some people, but basically when you log into SSH, you don't need to use a password if you configure keys, public and private keys. So there's a very standard way in Linux to do that. You'll encounter that if you've ever done anything with GitHub. So fundamentally, one of the commands you're using a lot is this scp. This is a bash command, and it's a copy command. And what it is an SSH copy. So basically, you download you set up your host file, you set up a file in the Spark configuration which lists every slave that you have, again by name, like slave 01, slave 02, which in your hosts file relates to an IP address, then you would, so you have the Spark folder on your first Pi, your master Pi. You make the configurations. You use SCP to copy it with its configurations to all of your other Raspberry Pis. You can do it without a password at that point because that's already been set up. And then you're able to execute it from command line. So let me just briefly show you the next steps. So once you have a cluster, you're going to want to learn about PySpark, which is Python's version of the Spark API. Basically, you're going to see a lot of these .map functions. That's where you're saying, for something, do something to it. And that is where your parallelization comes from. You can work in Python, Scala, or Java. I will say there's a little bit of a learning curve to that, but work off of examples. One last thing, just to wrap up, again, check the blog for the technical details. MoCo Makers is looking for facility sponsorship, so if any of you guys have any facilities that you would be willing to host about 20 people in once a week, that would be a great resource to us. Check out other groups in the local area. There's Coder Dojo DC, Rockville Science Center, and a lot more on meetup.com, in particular in DC and Northern Virginia. And we meet every week, and we just have a bunch of random projects that we do. Thank you, and hope to see you guys around more often.